Hello Professor, my name is Gautam and I will be explaining the first problem of the homework 6. It is given that fxy of x comma y is equal to a 1 plus xy, and the limits for x is mod x is less than 1 and mod y is also less than 1. So we can say that x is between minus 1 and plus 1, and so is y is between minus 1 and plus 1. So for we have to find the value of a first, given that it is a valid joint density function. So we say that the double integral of x and y taking the limits of fxy x comma y is equal to 1. Now we know the limits of x and y, that is minus 1 to 1, and y is also between minus 1 and 1. So we substitute the limits and we calculate for a. So solving for a, we get the value as a is equal to 1 over 4. Now in the second part, we have to show that x and y are, we have to answer whether x and y are uncorrelated. So we know that fxy of x comma y is equal to 1/4 of 1 plus xy, and again the limits mod x is less than 1 and mod y is also less than 1. So first we solve for fx of x. We put the limits with respect to y, that is from minus 1 to 1, and integrate it with respect to y. So we get the value of fx of x as half in the limits for x between minus 1 to 1. Now similarly, so we calculate the value of e of x here. So we calculate the value of e of x here. Uh, that is e of x is equal to x f of x in the limits from minus 1 and 1. So that is equal to x over 2, and therefore x square by 4 when we integrate this from minus 1 to 1, and we get the value as 0. Similarly, fy of y is equal to 1 over 4 1 plus xy, and we integrate this with respect to x in the limits minus 1 to 1, and we get the value as 1 by 2 again. So e of y, again calculating it as we did for e of x, that is y f of y dy, and the limits for y will be from minus 1 and 1. So we again get, when we integrate this, we get the value as 0. Now we calculate for e of xy, which is equal to, again we put the limits from minus 1 and 1, similarly for x and y, and now we know the function that is e of xy is equal to xy fxy dx dy. So xy into 1 by 4 1 plus xy dx dy. So when we calculate for this, we get the value of e of xy as 1 over 9. Now we can clearly see that e of xy is not equal to e of x and e of y. Therefore we can say that x and y are not uncorrelated. Now we have to show the independence of x and y. So first we calculate the value of, as we have calculated the value of f of x, fx y as 1 by 4 1 plus xy, and fx of x is 1 over 2, and fx of fy of y is also 1 over 2. So basically, therefore fxy x comma y is not equal to fx of x into fx of y, as this is 1 by 4 1 plus xy, and this is 1 by 2 and 1 by 2. Therefore we can say that x and y are not independent. Now in the fourth case, we are asked to find the joint density function of x square and y square. So we assume x square equal to z and y square equal to w. So basically we have to find the determinant j, which is da by z by da by x, partial differentiation of z with respect to x, and z with respect to y, w with respect to x, and w with respect to y. So the partial differentiation of x of z with respect to x will be 2x, since it is x square, and for y it will be 0. Similarly for w with respect to y will be w with respect to y, this is y, and this is w with respect to x, that will be equal to 0. Therefore we get the value of j as, substituting the values here, we get the value of j as 4xy. Now we know that for calculating the fzw of z comma w, this can be written as fxy of x comma y over the determinant j. Now fxy of x comma y, we know it as 1 by 4 1 plus xy. So since x is equal to x square is equal to z and y square equal to w, so we will have 4 roots, that is root z, root minus root z, root w, and minus root w. So we will have four equations here, and when we substitute this, root z and root w minus root z, root w, then root z minus w, and minus of root z and minus root w. So when we substitute this, we get 1 by 4, 1 by 4 root zw, this should be here, the 1 plus root zw, 1 minus root of zw, plus 1 minus root of zw, and 1 plus root of zw. So all these four terms will cancel out, and what we get finally is fz as 1 by 4 root zw. Now we have to prove or disprove in the second part that x square and y square are independent or not. So fzw of z comma w will be 1 by 4 root zw. Z square, z is between 0 and 1, and w is also between 0 and 1. So we get we calculate this for z first. So we integrate it with respect to w, and the limits will be from 0 to 1. So 1 by 4 root of z, and when we integrate this, we get this as root w. So, and yeah. Yeah, but we get this as root w, and we put the value from 0 to 1. We get the value as 1 over 2 root of z. Similarly for w, we integrate this with respect to z in the limits 0 to 1, and we get the value as 1 by 2 root of w. Now fz of zw is equal to 1 by 4 root zw, as we got it from here. Okay, so this will be zw, 1 by 4 root zw, and fz of z is 1 by 2 root z, and fz of w is 1 by 2 root w. So basically when we multiply this is nothing but fz of zw. So we can say that fzw is fz, that is z and w are independent, so that is x square and y square are independent.